When discussing wormholes in part 3, you differentiate stationary gravitational versus moving electromagnetic types. Which do you see as the more viable path experimentally, and what exotic matter or fields would they require? A stationary gravitational singularity is known as a black hole, and a moving electromagnetic singularity is called a wormhole. The reason the black hole is called stationary and the wormhole considered moving is due to the fact that the black hole's entrance, its event horizon, always leads to its core, the gravitational singularity or singularities at its center, while a wormhole's entrance usually leads to a random and unpredictable location in space-time. For example, a stationary singularity that forms uh, from a stellar supernova can have spin, rotation, revolution, and polar precession, and still remain locked in its original location, thus forming a black hole. An apparently random gamma ray burst in deep space that is paired with another simultaneous burst somewhere else in local spacetime is considered a wormhole between these two points. Because it is predicted that any object or pulsed signal can travel from the entrance of a wormhole to its exit somewhere vastly distant at a nearly instantaneous speed, this phenomenon is also called a temporal singularity. Such a temporal singularity also occurs at a much smaller scale, almost constantly, as the so-called Compton effect. When a photon strikes an orbiting electron for the duration of the impact, the position and trajectory of the electron can be measured, but the photon cannot. Then, afterwards, this situation reverses again. Although this event usually takes little more than a Planck-time to transpire, it is still considered quantum tunneling, as the photon disappears and then seems to suddenly reappear in a different location, bouncing off the electron orbit at a trajectory altered by its impact.